Wronskian determinant. Wronskian determinant method is used to show any function that whether the given functions are the linearly independent or dependent. To show that, to check that whether the given functions are linearly independent or dependent, the Wronskian determinant is used. And what is that determinant? The Wronskian determinant is basically equals to some determinant. And what that determinant contains? That determinant contains the functions and their derivatives. The first row contains your all the functions. The second row contains the first derivative of that functions. The third row contains the second derivative of that functions up to the n-1 times derivative of the given function. Now, how many rows you will write or how many derivatives you will take, that will be determined by the number of functions you are given with. If you are given with 3 functions, then you will take the derivative for only f double dash, the second derivative. The derivative will be n-1 times. This is your n and the derivative will be n-1 times. So you will equate the functions and their derivative values in this determinant and find the determinant. That determinant is called your Wronskian determinant. Now how you will determine that whether it is the given functions are linearly dependent or independent. If your Wronskian give you 0 in your answer, then this means that the functions are linearly dependent. And if your Wronskian is not equals to 0, then this means it is linearly independent. The given functions are linearly independent. Now let's move on to the example so that it can be more clear to you. Check whether given functions are linearly dependent or not. You are given with 3 functions. Your f1 is 6, f2 is 3 sine square of x, and f3 is 2 cos square of x. You have to find its derivative. And what will be its derivative? First of all, find the first derivative. This is a constant term, so its first derivative will be 0. Find the first derivative of this f2. That will be equals to 6 sine of x cos of x. First of all, power down, power minus 1, and then the derivative without power function. Now the derivative of your f3, first derivative will be, it will be minus 4 sine of x cos of x. Now you are given with 3 functions, so you will find the derivative up to second time. So the second derivative will be f1 double dash will be 0 here. The second derivative of this f2 is, you will use here the product rule. After using the product rule, you will get here 6 cos square of x minus 6 sine square of x. Now from here, f3 double derivative will be equals to minus 4 cos square of x plus 4 sine square of x. You can simplify it further. You can close it by using an identity. Take 6 common. The rest of the thing will be an identity that is called cos 2x. Take 4 common and the rest of the identity will be called as cos 2x. Now write the Wronskian determinant, that is equals to f1, f2, f3, f1 dash, f2 dash, f3 dash, the first derivative. Now second derivative, f1 double dash, f2 double dash, and f3 double dash. Fill your determinant with all the values. Get here 6, 3 sine square of x, 2 cos square of x, here 0, 0, 3 sine of 2x, minus 2 sine of 2x, 6 cos of 2x, minus 4 cos of 2x. Now what identities I have used here basically? Sine 2x is basically 2 sine of x cos of x. So if you look at this value, we can just write it like this in this manner. And cos 2 of x is cos square of x minus sine square of x. So I just closed all these functions into some identities. Now This is the property of a determinant. You can take common from any of the row and from any of the column as well. So I am taking some common terms from the rows. From the second row, I am taking common 2. I am taking the common as sine 2x. I am taking sine 2x as a common from the second row. And from here, 2 cos 2x. What I will be left inside? I will be left with 6, 3 sine square of x, 2 cos square of x, and here I will be left with 0, 3 minus 2, 0, 3 minus 2. Now, this is the property of our determinant, that if you have two similar rows or two similar columns, then this means that determinant will goes to 0. So you will get sine 2x, 2 cos 2x multiplied by 0, and that will give you as a whole answer 0. Now if you observe your Wronskian is 0, then this means the functions are linearly dependent. So the given functions are linearly dependent.